All right, what is up, guys? Mr. Rushka here, just going to film the 5.1 lecture notes for you guys. I'm going to set a timer for 40 minutes, which I just started. Okay, so let's get through as much of these as we can for your e-learning day for Shamrauction, okay? So number one, part A. So first off, okay, so we've got the 5.1 notes here, all right? What you need for this whole chapter, this is your Bible, okay? You will not be able to follow along in these notes unless you also download this sheet of what are called trigonometric identities. Okay, so proofs are back. Sorry, hate to burst your bubble, okay? Proofs are back. All these identities can be proven starting, they're either definitions, so these are just definitions, right? And then the rest of them can be proven starting from this guy right here. Sine squared plus cosine squared equals 1. And that's true because if we draw the unit circle, I know I'm not supposed to prove stuff for you guys, but I really don't care because this is so important and I love it. So if we draw the unit circle, okay. All right, any angle, an arbitrary angle. Okay, let's just say I drew this guy. Okay, who cares? All right, it can be anything I want. Let's say I drew that guy. Okay. This angle right here, theta. Okay. Theta. Okay. This is just going to be some coordinate here. I'll just call that x comma y. All right. So the bottom of this triangle is x. The side is y. This is the unit circle. So the hypotenuse, right? The hypotenuse of this triangle, which is also the radius of the circle, is equal to 1. Okay. So then we have x squared plus y squared equals 1. But what did I say about these angles? So I said it about the quadrantal angles, but it works for any arbitrary angle. That x equals cosine of theta, and y is going to equal the sine of theta, right? And we can see this too, right? If we just look at this triangle, right? Sine of theta equals opposite y over 1, the hypotenuse. Cosine of theta is going to be my adjacent side, x, over the hypotenuse, which is 1, okay? Right? So subbing in these guys down here, we have that cosine squared of theta plus sine squared of theta equals 1. So that's how I show you in the picture. I just had to show you that, okay? Don't worry about it on the test. Just enjoy for your own pleasure, okay? And then all these other guys follow from this guy right here, okay? So let's go back to the notes and get started. Find sine theta and cosine theta if the tangent of theta equals 3/4 and sine theta, it's probably supposed to say less than 0 or greater than 0. Let's say less than 0 just for funsies. Okay, so sine theta is negative, tangent of theta is 3/4. Find sine theta and cosine theta. So we'll do what we usually do. Okay, draw a right triangle. Let's label that bottom angle theta. So tangent is 3/4. So the opposite over adjacent is equal to 3/4, okay? Let's fill in that third side with the Pythagorean theorem, okay? We know that the sine of theta is negative. The sine of theta is negative. So our answer is going to be, so sine is negative, tangent is positive. That only occurs in this quadrant here. So our answer is going to be in the third quadrant. Remember, we have 180 degrees on the left side. Okay. So it's going to be this, our reference angle is going to be, we just use this triangle. Okay. So using this triangle, we see that the sine of theta is 3/5, opposite over hypotenuse. The cosine of theta is 4/5, adjacent over hypotenuse, okay? And then since we're in the t quadrant, both my sine and my cosine are going to be negative, okay? That's a good little warm-up problem. I think this one's a little clearer. It says tan theta is less than 0. So find sine theta and tangent of theta if cosine of theta equals 4/5 and tangent's negative, okay? So let's think what quadrant we're going to be in now, okay? Tangent's negative, so we're going to be in either one of these two quadrants, Okay, tangent is positive in the A and T quadrants. And cosine's positive, so that narrows us down to this fourth quadrant here. Okay, so let's draw a right triangle just like we've been doing. All right, we've got theta down here, right triangle. Cosine is adjacent over hypotenuse, so 4 over 5. All right, use Pythag for the third side, boom, same exact triangle, okay? And then just use this triangle to find the sine and tangent of theta. So sine of theta, that's the opposite over the hypotenuse, which is 3 over 5. Cosine, or I guess we need tan theta, sorry. Tan theta is going to equal the opposite over the adjacent, 3 over 4. And we're in the C quadrant, so both of my answers need to be negative. There you go. Nice little other warm-up problem, okay? All right, now things get a little trickier. Now we're using our handy-dandy trig identity sheet, okay? So if you guys want to print that out or have it like on your phone next to you while you watch this video, that's not a terrible idea. I've got it on a piece of paper next to me. I'm not just going to keep flipping back and forth. Okay, but there's an identity on there that I'm going to use for this first one. It says that tangent of x, or tangent of theta, the variables are kind of arbitrary. So I'm going to say tangent of x equals sine x over cosine x. So what I'm going to do, I'm going to rewrite this tan x here. This is tangent x times cosine of x. I'm going to rewrite that tangent as sine x over cosine x, okay? And then I still have the times cosine x there, all right? These two cancel, and my answer is sine x when I'm all simplified, okay? So I just subbed in that equation. All right, let's go to B. 1 plus tan squared of x over cosecant squared of x. Okay, well, there's an identity on here, right here. Okay, let's use that identity. So 1 plus the tangent squared of x on top is equal to the secant squared of x. And that's still over cosecant squared of x. And I just got that equation. I went from here to here just from that equation on my identities sheet, my reference sheet, okay? I know the sheet says honors, okay? We'll just have more than we need for academic, okay? Good stuff. So this is secant squared x over cosecant squared x, all right? One thing you can do, right, secant and cosecant, I can change these. So if I can flip-flop this around, I can put cosecant squared in top, and it becomes a sine squared of x. And I can put secant squared in bottom, it becomes a cosine squared of x. So this becomes sine squared of x over cosine squared of x. All right? And again, let's go back to this identity right here. Sine x over cosine x equals tangent x. Similarly, sine squared x over cosine squared x equals tangent squared of x, okay? So I'm just making some of these leaps from line to line. I'm making pretty much all of them just with my identities worksheet here, okay? You get better at these over time. What happens is you see them, you start to remember all of them, and you see them so much where you can just like look at a problem and see, oh, this kind of just collapses down to this. Imagine if you guys looked at an equation that said like x plus 1 equals 0, and you kind of just saw, oh, x equals -1. That's what starts to happen with these over time as you get better at them. So if you're stressed out right now, don't worry, okay? Just need practice. All right, sine squared of -x plus cosine squared of -x. Well, this principal identity here, right, what this means is theta can be anything. Theta can be anything as long as what's inside my sine squared and what's inside my cosine squared match, which they do here, right? This whole thing is going to equal 1, okay? It could be sine squared of fish plus cosine squared of fish. It will equal 1, okay? All right. Part D. Okay. how do we want to do this one? Okay, so one of my identities, tangent of x equals sine x over cosine x. That's one identity. All right, what is cotangent, guys? You remember cotangent? For cotangent, we just take tangent and flip it over. So the cotangent of x is just going to be this guy flipped over. All right. So the cotangent of x is cosine x all over sine of x. That's the cotangent of x, okay? So let's sub these in, okay? We'll sub the blue guy in right here. We'll sub the purple equation in right here. So that becomes sine x times the quantity sine x over cosine x plus cosine x over sine x. All right? Good stuff. So now let's distribute. So that becomes sine squared x over cosine x plus cosine x, right? That sine times cosine over sine, that's going to cancel. Okay, that sine is going to cancel with what's in the bottom here, okay? You'll get just a cosine x there, all right? So let me take a look at the key. All right, so good stuff. Okay, so now let's combine these into one fraction. Okay, so this is a fraction right here. It has a denominator of cosine x. This is also technically a fraction here on the right with a denominator of 1. So to get the denominators to be the same, I'm going to multiply this fraction on the right by cosine x over cosine x. Okay, and that's going to give me sine squared x over cosine squared, just cosine x plus cosine squared x over cosine x. Okay, combining those two into one fraction, right? When I add fractions together, just like in elementary school, I just add across the top. It's going to be sine squared plus cosine squared over cosine. What is sine squared plus cosine squared always? It's 1, okay? 1 over cosine x, which is, if you look at your trigonometric reference sheet, is just the definition of secant x. So there's our answer, secant x. All right, you just get better at these over time, okay? Okay. All right, let's do E. Let's do E real quick, okay? So secant squared minus tangent squared over cosine squared plus sine squared, okay? Well, you guys should know, you guys should start to see this. This should start to become muscle memory. I've got a cosine of something squared plus a sine squared of that same thing. What is that always? It is always, 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 always equal to 1, okay? All right, and then secant squared minus tangent squared of x. What is that equal to, okay? Let's think about what that might be equal to. Let's see if we can use a trig identity, okay? So here's an identity right here that relates secant squared and tangent squared. All right? What I'm going to do is I'm going to go ahead and in this identity, so I'm going to I'm starting from this pink highlighted identity here. Okay, I'm going to subtract a tangent squared of theta from both sides. Okay, that'll cancel. That's going to give me 1 equals secant squared theta minus tan squared of theta. Okay, so secant squared minus tangent squared equals 1. And that's just an equation that we get from our reference sheet here. You guys are going to get really good at using this. You're going to use it. It's going to be your best friend. It's going to be, right, I'm going to have to, right, instead of telling you to put your phones away, I'm going to have to tell you to put your reference sheets away. That's how much you guys are going to love it, okay? So secant squared minus tan squared equals 1. Let's go back to here. What do we got in the top? We've got a secant squared minus tangent squared. Wonder what that equals. It equals 1, okay? So our answer is 1 over 1 which also equals 1. Okay? Wow, crazy. This expression simplifies all the way to 1. Fun stuff. All right, let's move on to F. Let's move on to F. Okay? All right. So here's what I'm going to do. Let's think about it this way. So I'm not going to worry about this sign right now. I'm just going to copy this down here onto the next line, the 1 over sine squared of x. This other term, I'm going to rewrite that as secant squared x times 1 over tan squared x, right? And I can do that, right? Dividing by the tangent squared of x is the same thing as multiplying by 1 over that, right? That's just how fractions work, okay? So secant squared, so secant is 1 over cosine. Secant is 1 over cosine, so I'm going to use some highlighter for you guys. Let's highlight this in pink. Highlight this guy in green. All right, and we're just going to copy down that 1 over sine squared again, okay? I'm going to copy that down to the next line. That pink secant squared I'm going to rewrite as 1 over cosine squared of x. That's because secant equals 1 over cosine. Okay? Then that 1 over tangent x, I can rewrite that as, well, let's think about this. 1 over tangent squared x is the same thing as cotangent squared of x, and that equals cosine squared x over sine squared x. Okay? So then this is going to become a times cosine squared of x over sine squared of x, okay? Again, down to the next line, we're going to come down here. Just copy that 1 over sine squared x. We're just letting that guy chill for now. Right here, when I multiply these pink and green numbers together, the top and bottom cancel. And I have plus 1 over sine squared x. Okay? We have two fractions here with the same denominator that we're adding together, so we're just going to add across the top. That'll give us 2 over sine squared of x, right? And 1 over sine squared, and my identities sheet, right? 1 over sine is cosecant, okay? So that's right up here, right? Cosecant equals 1 over sine, all right? So 2 over sine squared is going to equal 2 times cosecant squared of x. Let me stop right now and pause. I'm not sure I actually explained this. But when you have a trig function, I'm just going to total aside, like total random aside. When you have a trig function, you guys see these exponents here, how they're written right next to the function. So here's how this works. So something like cosine squared of theta, right? That's just a fancy way mathematicians have of writing cosine of theta, that whole thing squared. So that's what the little number means right here. It's literally just an exponent around the whole thing. They write it right next to the letters just so we don't confuse cosine of theta squared and cosine of theta squared. Right? That's why they write the number, the exponent, right next to the letters, so you don't confuse that. Okay? Let's go back to our notes. 3a, solve. Okay? So 2 cosine x times sine x minus cosine x equals 0. These are just like in Algebra 2, except there's like trigonometric functions now. But we do the same thing. We factor, and then we set each individual factor equal to 0 and solve for x. So we essentially break up the problem by factoring, okay? So let's look for a GCF between these two terms. I've got a cosine here and a cosine here. Let's do that, okay? Let's pull out a cosine. So this is going to be cosine x times 2 sine x minus 1 equals 0, okay? So we've got two factors here, one in yellow and one in orange. All right, and we do this problem the same way we've always done, okay? I take this first factor here, I write it equals to 0 and solve. Cosine x equals 0, hit both sides with an inverse cosine. So I get x equals inverse cosine of 0. So x is the angle whose cosine is 0, okay? If you look at your quadrantals, those top and bottom angles, so x equals 90 degrees and 270 degrees are what's gonna, those are gonna be your solutions, okay? So that's one answer. I'm gonna do that in yellow just so we don't confuse it. All right, and then let's do the orange, okay? So we have 2 sine x minus 1 equals 0. Let's add 1 to both sides. Let's divide both sides by 2. Okay, so sine x equals 1/2. Let's hit both sides with an inverse sign. All right, that cancels. So x is going to be equal to the inverse sine of 1/2. So x is the angle whose sine is 1/2. If I draw my special right triangles here, I'm going to draw one of them. All right, this is 90 degrees, 30 degrees, 60 degrees, 1, √3, 2. Okay. Which angle here has a sine of 1/2? 30 degrees. Opposite over adjacent is 1/2. So our answer is going to be 30 degrees, and then let me draw my TSAC stuff. There's also going to be an angle with a sine of 1/2 of positive 1/2 in the S quadrant, and I get that. So 30 is going to be my reference angle, okay? So I'm going to do 180 degrees minus 30. That's going to give me 150 degrees. There you go. So those are your 4 angles that are going to solve this equation. Okay. All right, part B. Part B. √2 tan x cosine x minus tan x equals 0, okay? It's just the same thing. It's just like algebra 2. There's just that additional piece of the trig stuff, okay? So let's go ahead, let's factor out a tangent of x. So tangent of x times √2 cosine x minus 1 equals 0. So we factor, then we set each factor equal to 0 and solve. So I've got that yellow factor there and my orange factor here. Let's do the yellow factor. So tangent of x equals 0. All right, let's think about how we can solve this. Let's rewrite tangent as sine over cosine using our trig identities. All right, if we have a rational function that's equal to 0, that means I only need the top to be 0. So I can actually ditch the bottom. So my answer is going to be sine x equals 0, the angle whose sine equals 0. If we think of our quadrantal angles, that's going to be solved by, what does she want? Yeah. That's going to be solved by the angles on the left and right of my axes. Okay? So it's going to be 0 degrees and 180 degrees. There you go. Let's do the second factor now. √2 times cosine of x minus 1 equals 0. So let's get cosine x by itself. All right. All right, let's divide by √2, divide by √2. Cosine x equals 1 over √2. Let's hit them with the inverse cosine. So we have x equals inverse cosine of 1 over root 2. Let's draw our other special triangle now. So x is the angle whose cosine is 1 over root 2. Let's look at this triangle. Which angle has a cosine and adjacent over hypotenuse of 1 over root 2? Adjacent over hypotenuse. Yay! All right, 45 degrees. It's like an episode of Blue's Clues or something. All right, 45 degrees. All right, and then we're going to have another answer. So which two quadrants have positive cosines? A and C. So we're going to have another answer in the C quadrant. That angle on the right side of the axis is 360. Okay, so we're going to take my first angle is actually my reference angle. We're going to do 360 minus my reference angle to give us that other answer that's in the C quadrant. So 360 minus 45 is 315. So there you go. All right. I don't know if you guys can hear Miss White. I don't know if you can hear Coach White or not. Let's close the door just in case you can. All right. Let's put together a championship lacrosse program. All right. Cool. Okay, so now this is the same thing, but we're putting our answers in radians, okay? If I were you guys, I would just try to get your answer in degrees and then convert to radians at the end, okay? All right. Same things to solve. So the difference here, right, these two problems are already equal to 0. So the only thing we have to do here is we just have to set them equal to, we just have to get 0 on one side ourselves first. So we have to get 0 on one side. I guess that's a pre-step, the real first step. So subtract tangent from both sides of the equation. Now we have a 0 on one side of the equals sign. Okay, and then we're going to factor out a tangent. I've got a tangent in both of these terms, so let's factor that out. There you go. And then, again, we've got two terms here. We're just going to set both of them equal to 0 and solve, okay? So for this guy, we literally just did this in the last problem. Tangent x is going to equal 0 when x equals 0 degrees and 180 degrees. Rewind this video about 2.5 minutes to see an explanation for that. For this one, we're going to have sine squared x minus 1 equals 0. So let's get sine by itself first. All right. Sine squared x equals 1. Let's take the square root of both sides to cancel out that little 2 there. So we have sine x equals positive 1 and sine x equals negative 1. Okay? Plus or minus the square root of 1. Sine x equals positive 1. All right, let's hit both sides with an inverse sine. So x is going to be the angle whose sine is positive 1. On our quadrantals there, that's going to be 90 degrees. But we want our answer in radians, so that's pi over 2. Okay? Right here, let's hit both sides with an inverse sign. I'm doing that to break the x out of the sign because I want the x by itself. It's just like solving equations in Algebra 1. Get x by itself, okay? So then the other answer for x is going to be the angle whose sine is negative 1. So we're going to go down 1 from the origin. All right. That's going to be 270 degrees, which in radians is 3 pi over 2. there you go. Part B, let's get tangent by itself first, okay? So I'm going to hit both sides with a square root. That'll cancel out that 2. So we have tangent of x equals positive root 3, and tangent of x equals negative root 3, okay? So tan x equals positive root 3. Let's hit both sides with an inverse tan. All right. This is actually, stuff like this is on your chapter test next week, okay? So you got to know how to do it. X equals the angle whose tangent is root 3. Positive root 3. Okay, so let's come up here. Which angle here in this triangle has a tangent, an opposite over adjacent of root 3? It's going to be 60 degrees. So x is going to be, so one of our answers is going to be 60 degrees. That'll be the answer from our A quadrant. And then our answer from the T quadrant, where there's also positive tangents, is going to be 180, that number on the left, plus my 60. So 240 degrees. All right, let's look at this tangent of x equals negative root 3. So x equals the angle whose tangent is negative root 3. Okay, if we go up to this triangle, right, we've got an angle with a tangent of positive root 3, okay? So we're going to use that as our reference angle. So let's reference, we're going to reference 60 degrees. That's not one of our answers this time because it has a tangent of positive root 3, which is not what we're looking for, okay? I want the angles now that are in the S and C quadrants. So for the one in the S quadrant, I'm going to do 180 minus my reference, 60 degrees, so it's going to be 180 minus 60. For that angle that's in the C quadrant, I'm going to do 360 minus my reference. So 360 minus 60 and 180 minus 60. All right, and again, they want all of our answers in radians. Okay, so 60 degrees is pi over 3 radians, right? I just multiply by pi over 180. Okay, we've been doing this for a while, so then we're going to have 240 pi over 180, cross out the zeros, divide by 6, it'll be 4 pi over 3. So these are going to be our two answers here. Convert these two to radians. Okay, we're going to get 2 pi over 3, and what will that be? 30 divided by 3 is 10, 10 pi over 6, 5 pi over 3. So those are going to be my 4 answers here, okay? So it might seem like a lot, but you got it. All right. Let's do this next one, right? First step. Let's get a 0 on one side. So we're going to subtract over that sign. Okay. Now let's factor, set equal to 0, and solve, okay? So we're going to factor out a sine x from both terms. All right, and then we set each, we've got 2 factors here. We can set them both equal to 0 and solve. All right, so let's set sine x equal to 0. All right, I did that in this problem back here on our quadrantals. Okay, so it's going to be x equals 0 degrees and 180 degrees. That's going to be 0 radians and pi radians. So that's going to be one of our pairs of answers. Let's highlight that in green so we don't confuse. Now let's solve the orange part, okay? This is going to give us tan squared x minus 1 equals 0. So let's get just the tangent by itself first. So we get tan x equals plus the square root of them, so positive 1, and tangent of x equals negative 1, okay? So let's solve this, okay? I'm going to draw my triangles again over here. All right, and then T-sac, or sexy tiger cat. Okay, so what's going to solve this equation? Let's hit both sides with an inverse tan. So x is going to be equal to the angle whose tangent is 1. So let's look at our triangle. What triangle here has a tangent, an opposite over adjacent of 1? That's right, Boots. It's 45 degrees. Okay, so 45 degrees is going to be one of our solutions to this. All right, remember we're going to end up converting that to radians. All right, let's save that for the end. And then there's going to be another angle on our axes. We're going to use that 45 degrees as our reference angle with a tangent of positive 1. It's going to be in the T quadrant. So we're going to use that 180 on the left, add our reference angle of 45. That'll put us in the T quadrant. That'll give us, 225 degrees, okay? If we convert those to radians by multiplying those numbers, those degrees, by pi over 180, we'll get pi over 4. And then that other one would be 5 pi over 4. So those are our two answers there. Okay, so we're up to 4 answers for x. Oh, man. All right, and then over here, hit both sides with an inverse tan to get x by itself. We want the angle whose tangent is negative 1. Okay, so here in my triangle, I'm going to use as my reference angle 45 degrees because the tangent of 45 is positive 1. And then I want the two angles that are in the C and S quadrants. So I'm going to do 180 minus my reference for one of my x's. And then my other answer is going to be 360 minus my reference. That gets me in the fourth quadrant. Okay, so that's going to be 135 degrees. Sorry, I'm running out of space. And what is that, 315? Yeah, 315 degrees, okay? If we convert those both to radians, we'll get x equals, and then what is that going to be, 3 pi over 4. So we multiply our degrees by pi over 180, and then what is that, 7 pi over 4? So those are our 6 solutions. Yay. Said 6 solutions. Fun. So all 3 of the green highlighted things. Okay. Cool. All right. D. Okay, scary, 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 okay? 4 cosine squared minus 4 cosine x plus 1 equals 0, okay? Scary. Okay, so you guys learned this in Algebra 2 last year, okay? So let's solve for cosine first. Let's just solve for cosine, okay? I'm going to do what's called a u substitution. I'm going to set u equal to the... So we've got a cosine squared, just a regular cosine, and then a nothing. When you do a u substitution, you set it equal to the... I guess cosine x is what we're solving for. You set it equal to the guy in the middle. Not the constant term, not the squared term, but the thing that's next to the term in the middle. So cosine x. We're going to set u equal cosine x. Then u squared equals cosine squared of x. Oh, this will be our last problem. Oh, okay. Okay. So it's going to be 4u squared minus 4u plus 1 equals 0. So let's solve this just like we did in Algebra 2. I'm sorry, I have to write out the factors myself. I have to write out the factors. So u, minus, minus. I didn't give myself enough space. Sorry. U, minus, minus. Okay, so this is going to be 2 and 2, right? Yeah. 2, 2, 1, 1. Good. Okay, yeah. So, yeah. Yep. So that's correctly factored, okay? And then we're going to set, I only have to set one of them equal to 0. We're going to set my factors equal to 0 and solve for u. We get u equals 1/2. And we'll get the exact same answer if we set this second factor equal to 0 and solve. So we have u equals 1/2. Okay, now let's sub back in my cosine. So I have cosine x equals 1/2. Okay, boom. So that's how I can solve. I want to solve for cosine first, which I just did. And now, just like good old times, we hit both sides with a cosine, with an inverse cosine. We get x equals the angle whose cosine is 1/2. All right. Well, what angle is that, you may ask? Okay, let's look at our triangles up here. Okay, what angle here has an adjacent over opposite of 1/2? It's going to be 60 degrees. Okay, so 60 degrees is going to be one of our answers. It's also going to be our reference angle. The other one is going to be, so it's cosine of 1/2. It's going to be that other quadrant that has positive cosines. So it's going to be, our answer is going to be in the C quadrant. So we're going to do 360 minus that reference angle. So 360 minus 60, which is 300 degrees. And then multiply them both by pi over 180 to get your answer in radians. There you go. So those are your two answers, okay? Thanks for bearing with me, guys. We'll finish these last two the next time we take notes. All right? Please watch this video. Bye.